Assalamualaikum warahmatullahi wabarakatuh. My name is SHAMHAN bin Mahmood. Today I will present UGP Project 1, Mode 2 Interlaminar Fracture Toughness of Wire-Mesh Steel Reinforced Epoxy Composite, supervised by Associate Professor Dr. Muhammad Yazid Yahya. This is a presentation outline, start from introduction, literature review, methodology and expected result. Introduction, a composite is a material made from two or more constituent material with significant different physical or chemical properties, which fiber plus matrix become composite. Sample use on composite, this is a sample Boeing 7878. We know about 50% of the body parts of the aircraft Boeing are made from composite. The stainless steel wire mesh is a warp and wave woven, mainly used for the filtration, screening of gas, liquid, solid and separate of media, and resistant for acid and alkali and high temperature. Why wire mesh steel? The strength to value of structure composite is known to be low. At the reason, this is a brittle of the fiber. The composite ductility and overall toughness can be enhanced by choosing fiber. Recently, a new class, but ductile fiber became available for application structure composite, which exhibit good height stiffness. The stiffness of such steel fiber is almost high as that of a carbon fiber, and strength to value is the height of stick fiber up to 20%. Why use stainless steel wire mesh? Stainless steel is very popular and versatile for consumer product. Abundant shape and size, useful for many application. By example, used for strengthen the concrete beam and for put in hydraulic filter. This is a potential application wire mesh on ballistic. Composite layer effective reduce the velocity of projectile due to high fracture toughness. As a result of reinforced steel wire mesh layer in composite. Advantage of the steel wire mesh is corrosion resistant, stain resistant, anti-oxidation, wear resisting. Wire mesh can be coated with PVC. Stainless steel mesh can easy to be cleaned. Example in filter. The matrix provide the medium for bonding into the solid when they reinforced together. Type of matrix, we have three type of matrix. First, metal composite. Two, polymer or matrix. Three is ceramic matrix. Resin is known as a matrix, important element in stainless steel composite. Resin are also referred to as a polymer that are defined a large molecule form by repetition of small and simple chemical units. There are two main groups. First, thermoplastic. Second is thermosets. This is epoxy will be used in this research. The type of thermoset, density 1.1 to 1.4, tensile 2.1 to 5.5 gigapascal, and tensile strength 40 to 85. Why use epoxy resin? Low shrink during cure, excellent moisturizer, excellent chemical, good electrical, increased mechanical effective strength, and impact resistant. Tensile test on steel. The weave process stainless steel wire mesh fabric more flexible and universal use. No need to punch like this. Just use the wire mesh machine. Problem statement. The major problem for the laminate composite is delamination. Delamination is the most common mode of failure for the composite laminate, and hence it the most feared situation. Delamination of effect with surface composite can be peeled off layer by layer. The delamination can invite to three mode: mode 1, mode 2 and mode 3. In this research, it will focus the mode 2 for stainless steel wire mesh reinforced with epoxy with three different weave. The objective to investigate the effect of different weave on the interlaminar fracture toughness in steel wire mesh reinforced epoxy. The scope of study is YMS T304 with 3 width, plain width, 3 width and plain Dutch width, using testing mode 2 interlaminar fracture tightness with loading rate 5 mm per minute. For literature review, this is a list for literature review before previous study. Start with type of fracture partners, the 3 way of applying force. Mode 1 is opening mode, mode 2 is sliding mode, and mode 3 is tearing mode. Like a picture, Indonesia use mode 2. For mode 1 and mode 2 interlaminar fracture tightness, bicarbon nanofiber, we know this graph is show the effect of density. We can see at the graph carbon fiber reinforced plastic at the 20 gram meter square have the highest 2 or 3 times higher than original carbon fiber. This is show that density when it affect the load for this versus displacement. And this research show the mode 2 interlaminar fracture tightness or interface layer 0, 0 show the highest value, G2 for all specimen, and interface layer of 45/45 show the lowest value. This is the effect of energy absorption. This is a rate sensitivity. We can see this is a slower rate graph. It's the intermediate graph in the over speed 3.2 millimeter per second. We can see at the slowest graph produce a non-linear graph, intermediate near to linear graph, and over speed 3.2 get the linear graph. This is effect of toughness of loading rate, toughness and loading rate. We can see for effect metric toughness macro graph in figure 7 and figure 8. But similar metric hex mark deformation metric composition which seem support the conclusion of no metric effect. For loading rate, surface micrograph show the composite lowest at the highest test at 1 mm, and 1 mm is here, 3 mm is here, meter per second. Sorry, 1 millimeter per minute, and this is a 3 millimeter per minute. Figure 7 and 8 respectively. Between the rate, there is no significant difference. This support the conclusion, no rate effect for glass fiber and vinyl ester composite. For this test, aluminium and banana, GARB aluminium composite has the highest flexural, the highest flexural strength among counterparts also. The GARB with aluminum hybrid composite has highest tensile and load capacity when compare the two others. GABRB also exhibit a lower hardness value, which show that it's less brittle. Thus, is interfered that the inclusion of banana fiber, illumination via aluminium, influence the mechanical properties. This is a tensile behavior for hybrid composite of carbon fiber. The tensile test results show the performance of glass fiber reinforced plastic with stainless steel wire mesh at the middle layer is higher than other laminate. You can see the graph. The performance is higher than others. In the methodology, this is a procedure in the fabrication, the cutting, the placing layer by layer, fabricate composite, curing at temperature room at 24 hours, and fabricate composite. This is a show, start with measurement, the steel wire mesh, laminate by epoxy, vacuum infusion method, testing using N-notch flexural test, and result for ENF test. This is a material preparation, use steel 304. This is a mechanical properties, physical properties, and chemical composition, and epoxy resin 1006 will be used. The process I use a vacuum infusion method. It's a technique that use vacuum pressure to drive resin into the laminate. Why use vacuum efficient? Is a better fiber to resin, less waste resin, very consistent resin usage, unlimited setup time, and very clean. This is a vacuum infusion process. The stainless steel wire mesh fiber are placed at here. Peel it put above the arranged fiber layer as a mean to absorb excess epoxy resin. Then HDPE flow media is put above the fabric. HDPE put above the fabric. Ribbon sealant are around the material setup. Okay. Two hoses are placed to the top and below to material setup. Two hoses are connected. Hose are connected to vacuum pump and to resin trap. When the compression turn on, the setup we check prevent the air leakage. Epoxy resin mix with hardener 10/6 weight ratio is placed up. The epoxy is removed from the resin after the process finish, and the sample is left to be cured in 24 hours. This is a summary of test: plain width, twill width, and plain Dutch width. Mood test. This is a machine will be used at the lab, and this is a figure how to put specimen test in the machine. Okay, the next is calculation for Mood 2. This is a sample specimen with label. G2 is a component of strain energy release rate. P is the load. B is a specimen within. A is the initial crack length. Delta is the displacement. This is a sample before test with the initial crack, starter crack. We want to calculate the L, half of center to point, and P and displacement can get data from the experiment. This is a load versus displacement graph, which normal graph is here. This is here is a P maximum, and is a force for non-linear maximum force is here, non-linear force. So the next, this is sample data woven glass fiber and calculation. This is made by me. Process stating mode on woven glass fiber. This is machine testing and specimen. This is a load displacement in fracture test woven glass fiber reinforced epoxy composite. This is a result for the testing. We can see sample 1, sample 2, and sample 3 have a same pattern on the graph, which the P maximum around 120 Newton to 140 Newton around. This is experiment data in 3 sample, which A set 30 to 60. In this result, this is a G2 for non-linear and at P maximum. This is for sample 1, sample 2, and sample 3, and we have and non-linear for sample 1, sample 2, and sample 3. And for P maximum, G2 for P maximum, sample 1, sample 2, and sample 3. And this is average for non-linear, and this is average for P maximum. This is a sample calculation, which P76, B25, A30, displacement 3.4 can get from experiment L60, the length of here. After insert data above, result calculation is 83.58 Newton for G2. And result after using formula, this is all result for sample 1, sample 2, and sample 3. And expected outcome, it will increase fracture toughness compared than woven glass fiber. The composite ductile and overall toughness is enhanced. Okay, for the last, this is a project Gantt chart, final year project 1. Start from February until September, until now. Thank you very much to listening my presentation. I hope the panel can give me guidance to finish this. research. Thank you very much.